Zoom controls. Here they are. Here we go.
Okay. Yeah, I think it should be set now.
Zoom controls.
Let's take this one out. Okay, now it's 4 sharp. Welcome everybody to another of our tech talks. Today I'm very glad to introduce Radovan Bast. He works in the University of Norway, and he's a theoretical chemist turned research software engineer. He has worked at the Laboratoire de Chimie et Physique in Quantique in Toulouse. Also has been in the theoretical chemistry and biology in Stockholm. And after that, he has dedicated himself to write research software and teaching programming to researchers and leading the CodeRefinery project. And he's involved in building the community of Nordic research software engineers. As I mentioned, currently he works in the University of Norway, and he is also in the Norwegian infrastructure for research and education. And he enjoys a lot cross-discipline collaboration and teaching programming languages and tools to researchers. So today he will present to us the topic next steps to FAIRifying coding in an academic setting. Please, Radovan, the floor is yours.
Yeah, thanks so much. Thanks so much for the introduction. Thank you so much for the invitation. Thanks for joining. Actually, it's nice to talk through this virtual event organized by University of Tübingen. I spent 10 years of my life actually close to Tübingen. So it's nice to be back, at least virtually, and hopefully we get the chance to meet live and discuss. That will be wonderful. So I will speak about our work in CodeRefinery, what we do, why we do it, our lessons learned, and how we connect to fair practices, fair software development, what we see as challenges and next steps in the project, and how we can all make software even more fair. And I'm happy to, so I'm calling here from the Arctic. Snow has arrived. So one big topic in this talk will be fair software development. Some of the ideas that I will discuss are also discussed in this comment, which you find in the slides, and where if you are interested, you can read more, and I would be happy to discuss more details. So I will try to highlight some of the ideas presented there. And so I come from chemistry, computational chemistry, but then I spent 6-7 years in research, but then I got really more and more excited about coding, about computation. I currently lead the CodeRefinery project. The CodeRefinery project, I will say more about that. I think this is also the link how I happen to speak here, because I think somebody from the group, from the Cubic group, attended one of our workshops, enjoyed it, and suggested that I could speak to you and tell you more about it. So thanks so much for this connection. And so I spent time teaching coding, mostly to researchers, supporting research in computation, in programming, in my spare time. I mean, I do enjoy programming. There is not very much time left, but I spent some recreational coding in computational chemistry and computational geometry, working with groups in oceanography. But enough about me. Let me tell you a few things about the CodeRefinery project, what we do, where it comes from, where we want to go, and then I will all connect it to FAIR software principles. So in this project, we teach tools and practices for reproducible, reusable research software. And here on this map, so we have given a number of workshops over the last 5 years. If you follow here, there is a full list. So many workshops. The ones that are in the water, the 2021, they happened online. So in 2020, like many projects, we have switched to online teaching, and I will share also some of the lessons learned from that. Our goal is to advance fairness of software management, fairness of development practices, so that research groups can collaboratively develop, review, discuss, test, share, reuse the code. And I think this also really resonates with the group here and the work you do. The history of the project, this grew out of a 1-week course that we gave at KTH Stockholm back in 2014. And over time, it grew into a Nordic projects. So we gave, since 2016, 31 full workshops. So we used to have a roadshow of traveling to different universities and giving workshops in these topics. Also instructor training events. And over the years, we have trained over 1,600 persons, which is really significant on a Nordic scale. Of course, we want to also go beyond the Nordics. The reason why we were focusing on the Nordic region is the funding. And this became really a big thing. So the recent workshops, we were able to really involve many volunteer instructors, volunteer helpers. And very recently, we got the good news so we have now funding for 3 more years. So there will be more CodeRefinery coming up. Very excited about that. And a typical curriculum is, so we teach Git, version control, both for in a single person setting, but also in collaborative Git. We teach code review, social coding, open software, software licensing, reproducible research, fair software, Jupyter notebooks, how to document code, how to test code, how to design code to allow for modular code development. And these are really important topics that are often not part of the standard university curriculum. But more and more disciplines need these. Our workshops are really across all disciplines. And I will say something about that later. So when we started, we were doing workshops in person. It used to be 3 days, full 3 days. What we do nowadays is we teach these in 6 half days, split over 2 weeks. And if somebody's interested, here we have already the dates for next year. All our material is online. It's open, it's Creative Commons. We are now in the process of making these lessons citable. We really want this to be accessible and reused and adapted. And we really welcome all contributions and suggestions. And maybe you have heard of carpentries, software carpentry, data carpentry, library carpentry. This is a very big organization worldwide that teach basic programming and data science skills to novices. We use many of the same pedagogy tools, so a lot of interactive teaching exercises. But if somebody asks me, so how do we compare to the carpentries, I see our project as the next logical step. So I think we are a good workshop to attend to after a basic carpentries workshop. And then maybe we manage to bridge the link towards more specialist training, which are typically run by computing centers. And in 2020, things changed everywhere. We had to adapt the training. And Richard Bast, my colleague from Aalto University, Finland, who is also here in the call, had really pushed the envelope and suggested that we use this as an opportunity. Since we have the tools, why don't we try to reach as many people as we can through streaming, Twitch, or through some of the tools that I will mention. So we have really managed in 2020 and 2021 through really effective teamwork to scale up instead of scaling down. It really increased our impact. So before 2020, we typically had 25, 30 participants per workshop, typically 2 helpers. Nowadays, routinely over 100 participants. Just this morning, we were participating in a workshop led by Aalto University, where we are teaching Python to And on Monday, we had 500 people following this course. Many helpers are needed. What we do is we alternate lectures, short segments of lectures with code-along exercises. We stream and also record the main room. But then we encourage participants to work through exercising groups in breakout rooms, which are not recorded. One concept that works surprisingly well, that we are really happy with, is to encourage participants to register as a team and bring their own breakout room. And then the team can even bring a helper or an exercise lead. And this has the advantage that the team already, they know each other. Often they speak the same programming language. They are from the same academic domain. And this can be really effective. To organize workshops on this scale, we also need dedicated installation sessions. We need sessions where we prepare helpers for this undertaking. We are also very happy with the system that we take questions and answers asynchronously via a collaborative document. And we even publish these later without, anonymized, but these questions and answers can be really, really valuable. And if you're interested in the teaching technique and what we learned, so we have more resources here, operational manuals. We wrote a blog post about it. There is a recording about a talk where we explain more about the challenges and lessons learned. And over the years, we have accumulated really lots of encouraging feedback. It's so uplifting to see that what we do, it really makes a difference. Here is one such feedback that we got, I think, last year. So somebody really enjoyed the sessions. It was professional. We made use of this distance learning without complaining about the unnecessary limitations. It was a team effort, and it really warms my heart to get feedback like this. So I could show a lot more. Let me maybe give you some data about who the community is. Maybe a little bit less anecdotal and more sort of data. What is the community? What is the impact? Here we have analyzed pre-workshop surveys and post-workshop surveys to find out who is coming to these workshops, at which stage, career stage. So mostly graduate student PhDs, postdocs, researchers, but also undergraduate professors, engineers. If you are interested in the details, so here I link to the GitHub repository with, there is a lot more there. In terms of discipline, this is small font, but on top so we have most participants really come from engineering disciplines, biology, bioinformatics, chemistry, physics, math, computer science. We do not yet reach participants from humanities, social sciences. This can have many reasons. It can be the topic. It can be that they don't know that we exist, because of course we are in some sort of bubble, and how do we reach them? So there we need to do a bit more work. If you're interested what programming languages people use, mostly Python, MATLAB, R, also some compiled languages. I will not go here into detail through the survey data. We also know now about tools, about version control, automated testing, code review practices, documentation. I think one interesting data that I like to show is 3 to 6 months later after the workshop, we ask participants to give us some feedback on what has really changed in their workflow. And then we can measure, has, for instance, version control stayed the same, or did people start using it, are using them better? So we have some impact in terms of version control, collaboration, code review. There are some other sections in the material where we have maybe less impact. We also ask then the learners whether code has become more reusable, more reproducible, more modular. And indeed, there is some feedback. There is some impact there. I'm particularly happy to see the last one. Have you introduced tools to your colleagues? So there is an effect on people who haven't even been at the workshop just by showing it to a colleague. So let me move on to and reconnect to the title. So how about FAIR principles? How do we fit in there? What are the challenges? What can we do as resource software engineers? What can we do as researchers? So FAIR principles, it's about making data and code findable and accessible and interoperable and reusable. And here's some typical questions that I'm sure many of you have heard or even ask yourself. So in terms of findable, okay, on which of my external hard drives is my script? Very typical. Can you please give me access to your scripts? Can you give me access to your code, to your data? Interoperability, how can we convert file formats from one to another? And I wish I could reuse this visualization pipeline for my new data. So adapting code and workflows to new situations. And one thing that can be really fun to do is to ask this software reproducibility 10-year challenge if to try to build code from 10 years ago. And whenever I ask this question to somebody or to myself, it can make people a little bit uncomfortable. So a couple of uncomfortable questions that can come up is, can you still find the code? It's probably not on GitHub because, well, GitHub launched only 13 years ago. GitLab is only 8 years old. If you can find it, can you bring it to a well-defined state? Can you find the corresponding documentation? How about external dependencies that we have many of in Python and R? Have the versions been documented? Those of you who use Git submodules may also get a bit uncomfortable because they can become difficult over time. Have they moved any hard-coded paths? If you manage to really rebuild it, how do you know that it produces the same results as in the past? A very fun and interesting initiative that has been started are so-called repro hacks. And I'll give you some links. So this was started by Anna Cristalli and colleagues. And these are hackathons, short hackathons, 1 day, half a day, where a group of people try to sit together, take a paper, and try to rerun the paper. And this can be a lot of fun. It can be great learning. I actually recommend it to new master students, PhD students starting in the domain. And some of the once you start reproducing other people's work, you may find these sentences. I wonder whether you have seen them. I actually admit that I have even written them in publications because I really didn't know better. The software used in this study is available upon request. We have used a locally modified version of CodeX. And what does that really mean in terms of findability, accessibility, and reproducibility? And today the trend is changing. Publishing computational results will probably, without accompanying data and code, will probably over time become unacceptable. And here are some statements from a couple of papers. Okay, anything else than release of source programs will be intolerable. Programs should be published in source language. The scientific community should always be able to verify that the published program will produce the correct results. What is amazing to me is that these papers are not new. I really recommend to read this one. The publication of scientific Fortran programs, it has many, I would say, groundbreaking ideas. I was stunned when I noticed that this is from 1969. This paper is 52 years old. Many of the things that I'm working on today were already formulated back then. Somehow they got lost over time, and now they come back into fashion. Now we are rediscovering them. And the journals are adapting. So here are some excerpts from editorial policies from Science and Nature journal that really encourage researchers to share data and code together with the paper. The reality is often different still. So when you approach a PI for the source code or intro data, you better explain who you are, who you work for, why you need the data, and what you are going to do with it. Of course, this can make sense for sensitive data. So sensitive data is different. All right, we have like 10 minutes left before question time. So let me look a little bit into the future. Well, it's interesting for me to compare how we share papers with how we share the code. When we publish papers, we actually want maximum visibility and maximum reuse. I think nobody is really actively trying to limit the visibility of their papers. In fact, the more interesting science is done, referencing my paper, the better it is for me. It's interesting for me to see that with code, it's different. What? I did all the groundwork and they get to do the interesting science? It's different with code, and I think there are a couple of reasons to it, and I want to explore them in the remaining time. But let me now come back to the FAIR software. What is it really? Here are a couple of good resources discussing this in the software context. I think FAIR principles have many aspects, and all of them are important. So it's about principles, it's about best practices, it's about policies, standards, governance models governing these standards and policies. We need tools, but I think we also need training and mentorship. I have highlighted the last two because these are the two that, this is where I work, this is where we work with the CodeRefinery project. This is where I'm trying to make a difference. I think all of them are important. I will now focus a little bit on the last two. One way of building mentorship into resource software development is code review. It would be good to make it a standard practice. It's not a new idea. Also, this was already voiced 50 years ago. There are two aspects of it. I think it's not just about the referees of the paper. It's also really about the colleague reviewing the code. So when we develop code, when we develop our data science pipelines, we review and we discuss changes before they are merged. And I think it can be really valuable when a junior student reviews code of a senior colleague. And this is one thing that I emphasize in our CodeRefinery workshops, is that this is not only about quality and about policing at all. In fact, the main motivation for this, it's a great learning opportunity. At least two people know about this change. At least two people understand it. It can be a both-way great learning opportunity. One thing I can also recommend, and it would be fun to hear whether you have that in your work, or to have code reading sessions where, like, I don't know, once every 2 weeks, we put code on a projector and we discuss it. And here is this whole workflow of how a research work is done. Then we document it in R Markdown or Jupyter notebooks. We put the code on GitHub or GitLab or Bitbucket. But then the work is often not finished. We also want to make it reproducible. We need to document dependencies. There are tools like Binder that allow to rerun it, our analysis interactively for anybody. And in CodeRefinery workshops, these are things that we teach, and how to make all of this citable. And in fact, this morning we were teaching this in the Python workshop. And I think here mentoring can enter. So let's spend the remaining minutes on discussing some challenges. I have a feeling that we more or less have the tools, but what are we missing then? What can we do? I like to show this tweet. Okay, in the early days of my career, this colleague that I respect a lot made some changes, which made the code 50 times faster, but the colleague was then not credited. So I think one thing that we can do is improve credit. Credit is important to attract and keep the right people. Attract people into research software engineering and not lose them so that they go into some other work. One of the main incentives will be credit, and the credit is probably not money. We are not staying in academia for the money. There is more money somewhere else. But what would be really nice if people can show what they did in their CV, and if this counts. So we need to make it count. So let's create an ecosystem where such CVs count, and that we create and support career paths. And so I self-identify as a research software engineer. Research software engineer is somebody who is somehow in between software engineering and research. They can either come from research or they can come more from the software engineering side. It's a whole spectrum. And I think these positions also will be key in this training, mentorship, improving the practices. This movement of research software engineers is growing in different countries. Here I give links. Maybe most interesting for this audience is the one, so the German Society for Research Software. Here you find more links. There is a lot of activity, a lot to explore. I can highly recommend, if you would like to hear more about research software engineering and the life of research software engineers, I recommend you to check out the keynote of Vanessa Sokat given at the September RSC conference, The Stories We Tell Ourselves. They also, Vanessa also is one of the people behind this wonderful podcast about research software engineer stories. I think it's good to remember that, okay, we have all these tools and we have all these techniques and these cool languages, but it's good not to forget that we write programs for people. And also here, these are these quotes from this wonderful paper from 52 years ago. We write codes for other people to read and understand. It's good to not forget the people on the other side. I think what we will need to work on in CodeRefinery, but beyond, is that we help establish a culture and the need for training so that we support a culture of sharing, that we encourage it, that we credit it, and eventually that we expect openness. And I unfortunately don't remember who said it. It's not my idea, but I really like that, is that we can, when we credit academic work, we can use many different metrics, and all of them will be somehow arbitrary. You will get what you measure. But if we make openness, if we credit openness, at least everybody else benefits. And this is a challenge. It's not only for students and researchers, it's also a challenge for principal investigators, for editors, in our roles as referees or funding bodies or hiring committees. We really need to make a leap there. And I'm convinced that training will remain critical. One initiative that we started with Richard and others is sort of semi-bi-weekly stream where we talk about research software engineering. So it's the Research Software Hour. Please check it out. The recordings are on YouTube, where we talk about tools and techniques that really people need. And 2 slides are left. Some future challenge. So look into the future and some challenges. I think community building is really challenging. It's really interesting. We are now at an interesting point in the CodeRefinery project where we really need to work on this community building. Also convincing research that it's not just about other people. So when we motivate fair tools and fair principles, often we motivate that, well, it's good for other people because they can find it and reuse it. But what is good for others is also good for self. And often others is me in future. I like the quote by Enrico Gleran that my 2 major collaborators, academic collaborators, will be my past self and my future self. Learning through mentoring and sharing, making courses more accessible through streaming. I'm convinced that there is significant training demand, and also actually many people who are really excited about teaching tools and they enjoy teaching. We need to connect them across organizational borders, across national borders, across funding silos. Funding often happens top down, but then this enthusiasm of people who really want to help others, it's often bottom up, and how to connect these two is not trivial. I think we need to improve the situation together with researchers. It doesn't make much sense, in my opinion, to just decide something for them. I think we need to do it together with them. And encourage them to share something which may not be perfect, because it will never be. So sharing imperfect codes and scripts instead of never sharing it because it's not perfect yet. These distributed efforts, leading this, motivating it, coordinating it, it's not easy, but it's a lot of fun. I think we are really at a very interesting time. Again, there is the link to the slides. Some recommendations is it would be very nice for us. Like one way to support our training effort is to tell university management leaders about carpentries, about CodeRefinery. The more people ask for it, the easier it is for us to motivate to keep this going. Encouraging sharing, encouraging open source. Code review is so important. So if I can recommend two things, it would be version control and establishing code review within groups. Fair principles from the start. And attracting developers and with credit and with career opportunities. And this will also mean influencing hiring committees, that we don't look only at the number of papers, but also maybe at other metrics. I realize that my time is exhausted, but I will look forward to discuss questions. And thanks so much for your attention, and thanks so much for listening.
Thanks a lot for the nice presentation, Radovan. I have been looking at the chat. I think these are not only questions, but also comments. I think because we are not a huge group, I think maybe we can turn on our cameras, and then we can use the system of raising the hand. Or I can also help here if somebody is writing in the chat. And then we do it more interactive. I think this will help better for the discussion. So the first person that was making an interesting comment was Radovan Bast. I think you can comment it aloud.
Should I also stop sharing? Will that help?
Yeah, maybe, and then we can all see ourselves. Thanks. Yeah, there.
Yeah, I mean, I don't really have much more to say other than what I wrote there. But I've said something similar before, like your tools should be boring so you can focus on your science. So there have been sometimes cases where people do, like they're always using the most advanced tools and no one else is able to use it and build on them. And this came up when Radovan was talking about the reviewing of other people's code. Like how many times there is code not reviewed because it would just be so impossible.
Yeah.
And that should not be okay.
And a great comment, and I can add to that sometimes we get this question, or like what is the best programming language? What programming language should we use? Should we move from programming language X to the latest, greatest new tool? Which, I don't know, which web framework is the best? And I understand the question, but I think often it's not about the tool, but it's about people around me. So I can go to the best programming language, but then I'm maybe the only one in the group who can write it, which means that nobody will help me with reviewing, nobody will double check it, nobody will understand it. If I leave, then maybe all the effort will be lost. So I think the answer is often like, what do other people use? Sometimes it's not about the tool. So really good point about building code review into it. I'm also catching up here with the chat.
Yeah, the second person was Jung-Hoo. You can also comment loud.
Hey Radovan, thanks for the good talk. I was the one who went for your CodeRefinery a couple of years ago at Uppsala. So it was nice to see you again.
Yeah, great to see you.
Yeah, anyway, so just read briefly from my comment. So you mentioned this briefly in your talk. So one of the things, big issues is that the big graveyard of bioinformatics software. So usually the script written by a postdoc or a PhD student, they make it a very super amazing in this very highly published paper, and then they just leave the lab and all the funding runs out. So then the tool's abandoned. So what do you think is the ways we can sort of promote like continuous software growth, or what do you think to keep these tools running, or do you think it's a non-issue?
Oh, it's definitely an issue. I didn't know the expression graveyard of bioinformatics software, but I knew about like graveyard of, well, you can exchange bioinformatics by any other discipline. It's definitely an issue, because I think when we write these proposals for a project, we somehow, I don't know, somehow the forms imagine that when we write the software, at the end it's somehow done, and like a paper, and then we can like cross it off, and okay, now we are done, we can move on to something else. But then when the software is just like then slowly is decaying, and it's very hard to reactivate it. And it's such a pity. I think if like a postdoc spends on something 3 years, and then at the end it's not picked up and not reused, it's such a, I think it's really a shame. And what can we do about that? I was thinking that we were at some point we were discussing to create like mechanisms for adopting software, so that, I mean, it's a problem that not only research has. Many people like to create, not too many people like to maintain. The funding ecosystem is not really created for maintaining. It's difficult to get funding for maintaining because it's often not innovative. It's easier to get funding for something, for innovation, for creating. But then it's difficult to hand it off to somebody. To whom could we hand it over to? Maybe we can at least hand it over to the community. At least maybe we can make it open, document it, test it. So at least it's reusable. I don't know if other people have thoughts on that.
Now we have a question from Jennifer Budka.
Yeah, but it's not related to what you said before, so I don't know if someone else wants to react on that first, or should I just go ahead?
Yeah, just ask it. It's okay.
Okay. First of all, thanks for the great talk. I think it's really interesting, and I think at Cubic we already do a lot of that in our main work. And I'm really interested in the FAIR, like the acronym itself. So for me, it's like pretty intuitive that findable and accessible probably is solved with GitHub, because with that you can get to the code, you can maybe manage access there, and reusable, maybe you document the versions, or you have a Docker container. I don't know what specific code it will be, but I wonder how interoperability will be, like, how can I implement that? How can I, like, yeah.
It's a great question. I was thinking about that. I think the I in FAIR is the most difficult one. And I think it's already the most difficult one when it's about FAIR data, because then it's about data formats and about, I think already there is difficult enough. I think it's in this like FAIR software, it's even more difficult to have interoperable software. What it means for me, or like my interpretation of the I, is that it's about documenting the interfaces. So what are the interfaces to the software? It's about versioning. It's about dependency management. But I think it's really difficult to make any software interoperable with any other software. But clearly documenting dependencies, interfaces, API documentation, API versioning, all of this can be really difficult. This is what it means to me. But I would also love to hear good API design. I see on chat, yes. Yes, and also that is, of course, it's not easy. It's, again, something that, at least in the research, is, if somebody is not from computer science, is, I would say, never taught. It's something that one somehow adapts to through like pain and making mistakes.
Now we have a question from Toby.
Yes, it's also towards the interoperability. So maybe that goes hand in hand with the maintenance that John Ho mentioned before, and also with regards of the funding. So do you think it would be helpful if, for example, Nature or another big journal would require a minimum support for those publications, so they come back in 5 years and say, well, is it still there? If not, you have to retract it or something like that. Which, I mean, is horrible if it doesn't run, but would help to keep it interoperable also over time, not only between systems.
Yeah, it's of course always a balance that we can impose more and more requirements, but without, of course, we don't want to create too many barriers either. So I don't know what the answer there is. I think one thing we can do is, again, at least having some requirements on standards in terms of tested, documented, I don't know, containerized, dependencies documented, dependencies accessible. So at least this is something that I think we will be able to require over time. It will take really time. Really requiring maintenance from the journal side, I think difficult if we don't go hand in hand with funding opportunities. I think a key can also be, there will probably be a difference between small codes that are like one time, it was a, I don't know, supporting script that generated this result. There is maybe a difference with a library or a code that is used by the entire community. And that code, I think that should be also then recognized that some libraries and some building blocks are so central in the community that it would be catastrophic to lose the maintenance. And there we really need funding. And I mean, this has been recognized a couple of years ago in, like if you look at NumPy and SciPy, OpenSSL, but I think we need something similar also for academic codes. And I think this is also where the research software engineers can come in. And maybe they can help with this. Also catching up here with the chat.
Yeah, it's an ongoing discussion between Richard and Diana Lucen regarding this recreating and also putting a little bit of limit. What is your opinion about that?
So definitely, I think it's difficult, as you know, it's difficult to make things perfectly reproducible over the course of time. And I think it's okay to be 80% reproducible. And also checking out the next comment that with the pyramid metaphor. So I think for many small scripts, we cannot impose the same standards as we would impose on a project like NumPy, because then we would stop people from doing anything. And already now, I think, I mean, researchers are struggling because they get more and more to do. Now the data has to be fair, the software has to be fair, all these tools, all these layers, and there are more and more. And to explain these, to train these, to motivate why this can be good for them and to help them, it's a spectrum.
Sven, you have a question? You forgot it. We cannot listen to you.
Sorry, now you should be able to hear me, right?
Yes.
Yeah.
Yeah, sorry. Yeah, I was just smiling because I mean, to everything that we discuss now, there's so much to say, to be honest, and I'm afraid that the time will not be enough. So I want to invite you, if you're again here close to Tübingen, to come by for a couple of beers or so, because I think the team also would like to share what we have experienced, especially within the group, and so much you have said is so true, and we experience it by ourselves. Yeah, with respect to the pyramid paradigm, I also think that we should not over-engineer. Over-engineering is also what I consider bad practice. So, I mean, if it solves it, if it does the job, then it's fine, and then continue. I mean, if there is no added value to a small script you have written, I mean, why should I put it on GitHub, for example, or whatsoever? But I think it's still very important to make people actually aware of it. So to trigger a process of thinking, okay, can this, what I have written, add value to a community I'm in, for example? And then, of course, you need to know, and you need to have access to mentoring and teaching program, how this is actually be done. Because, I mean, to be honest, what we have learned internally about good architecture principles and about good API design, good coding practices, good programming paradigms, and so on. I mean, that happened way after we left the active university study, I would say, and this a steep learning curve, and I would say we are still really climbing up the hill with a good pace, I would say. But I mean, if I look back what I have written during my bioinformatics study, it's like, oh my God, what I have done there. But I mean, yeah, nevertheless, with funding, I think, yeah, I think it depends on the impact of the software. So, I mean, you mentioned NumPy and stuff like that. That has really a huge impact worldwide, and there are big initiatives that support these kind of open source software projects. But I think for smaller ones that are maybe interesting for a national level or so, I'm not aware of if there's anything like that in Germany, to be honest. But I'm happy to be corrected. So maybe this is something that we might need to make aware of to, for example, Deutsche Forschungsgemeinschaft or similar, that we are actually investing a lot of taxpayers' money from which software is created, and what the loss of money basically is in terms of that it is not maintained anymore, and people start to reinvent the wheel over time and do it again and again and again, and nobody actually knows that this problem has been already solved. And that brings me to my actual question towards the findable principle. So what we have learned from the findable is, I think it's not enough to put it on GitHub because of the fact that there is no metadata available, not controlled vocabulary ontology that a machine can interpret and understand, and also can, for example, aggregate information in the web. For example, I just looked it up. Schema.org has type definitions for software application that you can put into JSON LD and, for example, create kind of a meta search engine that collects information of software distributed on many platforms, because as we know, GitHub is only one of the open source platforms. So is there any effort towards that, to make use of the semantic web to actually find scientific software?
So fully agree with you that putting something on GitHub or GitLab or any of the other ones is not enough. And at least for two reasons. The one you mentioned is that to make it really discoverable and to use metadata, I think then I don't think there is like one solution for all the different disciplines. Different communities have their own archives and their own solutions. Some communities are further ahead than others. This is something that we actually don't touch so much upon, that we don't teach in our workshops, because we have participants from so many different disciplines, but that we at least try to point them to the solutions that we know of. But we encourage them to like deposit their code in a place according to, well, to do something that their colleagues do. And the other reason why it's not enough to put something on GitHub or GitLab is, well, I can delete my GitHub account, I can delete the Git repository, and then it's gone. So then we also need to go one step further. And so something that we do discuss in workshops is depositing code on services like Zenodo, But for some disciplines, maybe there are better places in terms of searchability, discoverability, and metadata.
Thank you.
And also coming back to your comment from earlier, I fully agree. I'm sorry that within the half an hour I was just glossing over so many important topics. I would love to talk much more about that, and let's meet someday and then discuss all these topics. Everything is so interesting. So little time.
Yeah, sure. I fully agree. I mean, 30 minutes is not enough.
Yeah. Do we have any other questions or comments?
Janis, yeah, okay.
Yeah, we have a Janis Hochmuth.
Okay, just reading a comment.
Oh yeah, okay.
So it's about code review, sort of multiple people do, but do you have a viable alternative to this for people who are not able to involve other people in code review process, for example? Does that leave only automated tests in trying to modularize as good as possible? Because sometimes we work in isolation for one reason or another. So what if I have no colleague to ask? And I think this is a great question. Maybe we can facilitate some network where we can pair up people for code review. Like, I don't know, hey, can you look over my changes? And as a return, I will look over your changes. Of course, people have to then probably talk the same programming language. But it is a problem if it's just like a single person project. I sometimes get that question in our workshops, and well, I'm way behind sort of with emails and with GitHub notifications, but I would love to get to help reviewing other people's code, because I learned so much from actually reviewing other people's code. Like they use something that I didn't know one could do, and wow, yeah, you can do this, all right. So I really learned a lot from watching other people work. And one thing that I didn't mention in the talk is that it can be really also super useful to watch, to follow projects. How do they communicate? Follow their code review, how do they triage issues? How do they prepare the releases? Great learning opportunity. But sorry that I didn't have a really concrete answer for that question. I think it's challenging. Maybe we can find a system to have something like what do you call it, like a pen pal, but for code review.
Yeah, if I may comment on that, we have a rewarding system within our group. So we have cupbearer titles basically. So you will be able to have to wear a cup for the next sprint iteration if you, for example, have excelled in doing so many reviews. So we brought into locally only this gamification approach, and this worked really well. Actually, I think the biggest problem is the reward. So if I invest my time, so I mean, this is a really noble attitude that you bring up, that you say, okay, I learn, and because I learn reviewing your code, I will do it. So this is a very intrinsic motivation, I would say. We had it also in the group. I think it was Jenny, right? You said it once. I like to review your code because I learn so much. And this is really cool. But I mean, we also know that we just have limited time. And yes, if there is intrinsic motivation is good, but if there is no external motivations, then I think it will be hard to build up a community that will do that just by itself.
Yes, great point. And there can even be intrinsic motivation, but there can be external friction. What if it's a different organization and I'm not sure even am I allowed to do it, you know, like reporting hours. And also thanks to Richard for the comment that now that many things moved online, we actually have an opportunity to open things up and to reach further and, you know, grow the community. But there can be also some barriers and silos.
Okay, do we have any other question? Okay, I think it was a really nice presentation and also a quite nice discussion. And as Sven said, time is always too short, but we will definitely like to have another opportunity to meet, maybe online or in person, and of course to learn more about your projects and how you are dealing with these specific challenges that you mentioned. They're still there, and to learn will be very nice.
I'm very much looking forward to that. So thanks so much for the invitation. Thank you for your time, for listening, for watching, and really looking forward to, thanks for your support and looking forward to discuss more of this.
Yeah.
Thanks so much.
Thanks a lot to everybody, and have a nice evening. Bye-bye.
Have a nice evening. Bye.